This video shows how to troubleshoot problematic strings. In this example, what we have is a TinyPix, and this TinyPix is set up with a string of about 100 nodes. So we have it coming out, and you can see it's going through. All of them are using the same test pattern up until we get right here. So what we have is we have a node here, and it's working, and we go down the line, and you can see this next node's not working. Now we know it should be working because what we've got here is the TinyPix application. So we're going to just go ahead and read the settings, copy them over. So we have 170 pixels set up. That's the maximum number allowed. We also have it set up for red, green, blue testing. And so we know that if we had up to 170 pixels attached, we should be able to have them all going through the red, green, blue test sequence. So we know somewhere in this wiring there's a problem. So what we need to do is simply cut out the node. Now this is not extremely uncommon. These are handmade. They're injected after they're all soldered. Sometimes they do go through testing depending on your vendor. Sometimes they do not. But this just happens. It could be wire break. There could be something wrong with a chip. There could be a whole variety of issues. So we just cut it out and retest. So what we're going to do, first of all, we have to kind of figure out where maybe the problem is. So what you might want to do is just give a wiggle to the wiring and see if we've got a problem. Now, again, we're assuming that you're doing output to all the pixels, so you know that it's not stopping here, because this is pixel number 16, this is 17. So we should have no problem at all with a full 170 pixels here. So wiggling doesn't seem to make any difference, so it does appear to be a loose connection. So we can make the decision at this point, either one, to cut out this node, because maybe the wiring problem is actually in the node that's operational and going over. Or we could cut right here and just wire in and bypass this pixel and save this node. So you could start there and lose this pixel, or you could go ahead and just skip it. So what we're going to do is we're going to go ahead and just cut right after. So what I'm going to do is turn off the power here, unplug it, and I'm simply going to come over here, and I'm going to pick a spot a little bit to the center here, cut that node out, and we're going to cut out this node here. This is what we suspect is our bad node into the trash can. I'm going to take my nippers here. I'm going to simply just strip all of them back. That creates bare wires there. And I'm going to do the same here. And you can see now that we have all the wires stripped. And again, using my nippers here, I'm just going to grab the wires, pull them apart, so that we can connect each one directly. And grab them off. Now, we separate them, and I'm just going to give them a little twist so that the wires all stick together, so that they're not going every which way when I solder them. And we'll do that to the source string here. And again, this should be powered off. You should never do this when it is powered on. Alright. Okay, now what I'm going to do is take my soldering iron. I've got a soldering iron over here, right here. And we're first going to just take some solder. And this is lead tin solder. And I'm just going to go ahead and pre-tin. And all that is just putting a little bit of solder on each one of the connections on both sides. Alright, I've now attached solder to both sides, and now what I'm going to do is just take, in this case, some 1/8 inch pre-cut sections. These are about 1 inch long, and I'm just going to slide them down the wire before we solder it on. And this will provide us a nice, good, waterproof connection once we make the splice. Now, of course, this is fairly simple in terms of matching these up because the colors match up perfectly. So again, now also make sure that if you've moved anything around, now normally the output should be going into the input. In these particular nodes, the input is the chip side. So the data is coming in, then going back out the side without the chip. So your vendor's particular nodes may differ. So be aware, you're going out and then in. Okay, so all I'm going to do here, this down. This can be sometimes a little tricky. And simply just solder these on. And because, of course, these are exactly the same strings, the colors match up. There's no need to do any kind of figuring out where things go. Okay. All right, so we have our connections. We just give them a little tug, make sure that they're all good, that we don't have any loose connections. Now in this case, I've got a little bit too much solder, so I'm just going to go ahead and nip that little bit of solder off. Slide my heat shrink tubing over all the connections. I'm going to use my, and this could be a torch like I have here. It could be just regular cigarette lighter. I'm going to heat those up. They're nice and hot. And we have a nice, good spliced connection now. So, again, output going into the input. Now, let's go ahead and attach our power again. Okay, and as you can see here, we now have our splice point right here, and you can see that we made a good choice. We cut out one node, and we can see that that node somewhere, something wrong with it, miswired, bad connection inside, who knows, but this is now a good string, and as you can see here, the other nodes past it are all working fine. So that's how you fix strings of pixels which have bad nodes, and again, this is not uncommon. In fact, in your display, don't expect that you won't have to do this while your display is up. So sometimes an investment in a cordless soldering iron using butane is sometimes a good idea, especially if you have lots and lots of pixels. Now, the process for different physical kinds of pixels, whether they be squares or whether they be strips or whether they be other kinds of modules, they all apply, just the differences in the method that you solder them.